All right, folks, welcome to our video, Laws of Exponents Part 2. Last time we talked about all of the rules that govern multiplying. This time we're going to talk about all of the rules that govern division. So I love this t-shirt. Exponents are number 6,302 to the 0 power. So in other words, they are number, based on what we learned last time. What are they, kids? They're number 1. Exponents are number 1. Exclamation point. All right. Let's talk about the Quotient of Powers rule. So we saw power times a power last time. Now we're talking about dividing powers. To divide two powers that have the same base, subtract the exponents. So it's keep the base, subtract the exponents. Here's the example here. Let's zoom into it and look at it. If a to the m power is divided by a to the n power, we keep the a and subtract m minus n for our exponents. Couple of rules with that. A cannot be 0. M and n must be integers. We're not dealing with fractions, rational numbers, or anything like that with our exponents, just integers. So, with that in mind, let's take a look at these examples so we can understand why they work the way that they do. Let's start with this one here. 2 to the 6th power over 2 to the 2nd power is 2 to the 6 minus 2, or 2 to the 4th power. Now, why can we subtract the exponents? Remember last time we talked about the y part, and the y part was because it's a great shortcut. Now, here's what I have if I take this expression and I write it out without the exponents. Now, if you stop and remember what you know about fractions, you can cancel a common factor top to bottom. And when I do that, 2 of them cancel out on each, and what am I left with? Well, I'm left with 2 to the 1, 2, 3, 2 to the 4th power. Now, isn't it nicer to take that and just subtract? And that's the trick we're using here. Same idea. X to the 4th over x to the 7th. Okay, we can do the same thing with this. I can take this and I can rewrite it as x times x times x times x over x times x times x times x times 3 more x's to make x to the 7th, and I can cancel out the ones that are in common. And we end up with nothing in the numerator, which really means we have 1. Think of these big slash throughs where we cancel it out as a big 1, because that's what x over x is. It's equal to 1 times 1 times 1 times 1. So 1 in the numerator, and x to the 3rd in the denominator, so 1 over x to the 3rd power. Now looking at how that was done here, keep the base, subtract the exponents. 4 minus 7, negative 3. Rewrite using a positive exponent the way we learned in class. Let's try some. Okay, so start from the beginning. Let me switch colors here. There we go. All right, so y to the 9th over y to the 4th. Well, that's y to the 9 minus 4, or y to the 5th power. D to the 6th over d to the 9th is d to the 6 minus 9, or d to the negative 3, which must be rewritten. Whoop, nope, that's not how it's rewritten. Try that again. As 1 over d to the 3rd power. Remember, multiplying repeatedly. An exponent tells you to multiply repeatedly. A negative exponent tells you kind of to divide repeatedly. That's why it ends up in the denominator. All right, let's look at the next one. Same idea. Keep the variable. This time I'm going to do the k's first. So k to the 6th over k is k to the 6 minus 1, which is going to be k to the 5th. And j to the 2nd over j to the 5th is going to be j to the 2 minus 5. So right now I have k to the 5th times j to the negative 3. The 5 is a positive exponent. So remember that this is already a fraction. You just don't see your over 1 because you don't need to write it yet. So this part that's negative with the negative exponent has to go to the denominator of the fraction. So k to the 5th stays in the numerator. J to the negative 3 becomes j to the positive 3 in the denominator. Last one of these, a to the negative 3 minus 5 times b to the 7 minus 2. Make sure you're looking at the same variable. It is common to accidentally look at 2 different variables and get the wrong exponent. Similar to the previous problem, you want to take this and say, all right, again, negative exponent, he's got to go downstairs. Or I should say he's got to go to the opposite part of the fraction than what he's in right now. Because that's a little bit clearer what we're talking about here. The opposite part of the fraction. Because if we were talking about a situation where that negative exponent was in the denominator, it would have to move up. But since this is essentially the numerator of a fraction with an invisible denominator of 1 right there, that's why it goes down to the denominator. All right, continuing with raising a quotient to a power. Okay, to raise a quotient to a power, raise the numerator and denominator to the power and then simplify. But you can do it the other way around too. You could simplify the insides first if possible, then raise each part of the fraction to that power. So let's zoom in on what we're talking about here. That's right here. So a over b to the nth power. So a over b, the fraction raised to the nth power, is a to the n over b to the n. A and b cannot be 0 here, and n is indeed an integer. Let's look at their examples that they gave us. All right, so for this first one, you take 3/5, and 3/5 is being raised to the third power. So we do 3 to the third power on the top and 5 to the third power on the bottom, 27 over 125. And here's something cool. You're not going to be able to simplify this fraction right here if you couldn't simplify the one inside the parentheses to begin with. Because now there's no common factors. I shouldn't say now. There's still no common factors. There wasn't before. There was no common factor to numerator and denominator before. And then when you cubed them, you didn't introduce any duplicate factors, so there's nothing to simplify. So when you raise a fraction that's in simplified form to a power, you get a fraction that's also in simplified form. All right, then this one, x over y, which we cannot simplify, just raise the top, raise the bottom. That's it. So let's try some. Okay, raise the top, raise the bottom. Now let's remember to stop and think about what these expressions, what this mathematics means. Squared means, okay, so let's think about what it means. It means m to the 4th over 5 times m to the 4th over 5. So when I do that, when I go ahead and actually apply that exponent of 2, it's just like I'm multiplying m to the 4th times m to the 4th and 5 times 5. So that's going to be m to the 8th over 5 times 5 is 25. Same idea here. Raise the top, 64. Raise the bottom. Now be careful. R cubed to the third power is like power of a power. That's where we multiply as the shortcut. If you don't remember that, stop and think. Well, r cubed to the third is r cubed times r cubed times r cubed, which is r to the 9th power. Okay, the -1 exponent on a fraction. This is what we called in our previous video the reciprocal maker. All you have to do to simplify that is flip the top and the bottom. Notice my exponents aren't changing or anything. So when I have a -1 exponent, that's a reciprocal maker. You can try it out in class with the calculators. On this one, be careful to make sure you raise the 2 and the t to the 6th, both to the third power. So that's going to be 8t to the 18th power. Over, and then raise the p to the 4th to the third power, p to the 12th. So far, we haven't had anything to simplify before or after raising to this power. We will see that on the next set of examples. H over 5f, the quantity to the -2 power. Well, first, flip the insides, and then make your exponent positive. Now, remember what squared means. 5 squared is 25, f squared over h squared. All right, the last 4 examples are a tad challenging. So don't panic when you see them. Just let's take our time and go through it and make sure we understand what's going on. Okay, so these are a bit more complicated. We're going to do 4 of them total. So I want you to remember that we have our rules about how we simplify these expressions with exponents, and I want you to also remember that we're going to adapt to the point to where we start, if we understand the concept well enough, you're going to be able to simplify them without focusing too much on the shortcuts, but a little bit more on what the heck are we even talking about here. So the first and foremost thing I'm going to do before I start this problem is I'm going to look and see, can I simplify inside this fraction? Well, indeed I can. Indeed I can. So when I look at the fraction, 3x y to the 5th over x to the 4th y, and I'm going to keep my parentheses and my -2 exponent, which I'll deal with later, I want to recognize that this is 3 over 1. Now I'm not going to be able to get rid of that 3, and I'm not going to do anything to that 3 until I apply this exponent. X over x to the 4th, however, that I can simplify. So what I want to do here is I want to think about how can I simplify that? It would be 1, it would be this invisible 1 minus 4. But what I can also do is, remember, I can cancel out the common factors top and bottom. So let's cancel this x to the 1st with one of these x's, leaving me an exponent of 3. And then do the same thing with the y's. Cancel out this y to the 1st with one of these y's, leaving an exponent of 4. So right now I have 3y to the 4th over x cubed raised to the negative 2 power, and that's a little bit easier now on with what I need to do. So I'm going to flip the insides, make it x to the 3rd over 3y to the 4th, and then I'm going to square top and bottom. So remember, power of a power, multiply x to the 6th. Write it out if you don't remember. Power of a power, multiply, so it'll be y to the 8th. And remember to raise that 3 to that second power, so it's going to be 9y to the 8th power. All right, so we have x to the 6th over 9y to the 8th. All right, next one. This time I don't have any coefficients, any numbers to deal with here, and I do have some negative exponents. So this is a problem where I think I'm going to go ahead and I'm going to split this up into 3 factors, or 3 parts of a product. So m, and I'm going to go ahead and subtract the exponents. M to the 4 minus negative 2, we'll come back to that. N to the 3 minus 7, and then p to the negative 3 minus negative 8. Okay, excuse that straight line parentheses at the very edge of the iPad. It doesn't want to let me draw a curve. So that's m to the, well, that's going to become 4 plus 2, so m to the 6th. 3 minus 4 is going to give me negative, 3 minus 7 is going to give me negative 4, so n to the negative 4. And then here, because minus negative is really plus, negative 3 plus 8 is going to give me p to the 5th power. Then remember, you've got an invisible fraction here with a 1 underneath. Take the part of the fraction that has a negative exponent and switch it. M to the 6th, p to the 5th, over n to the 4th power. 2 more problems and this video is over. Okay. 75, we have a to the negative 1, b to the 3rd, c over a squared, b to the 4th, and we're raising that to the 6th power. There's 2 different ways to do this. I can apply the exponent first, then simplify the insides second, or I can simplify the insides first, and then apply the exponent second. It really does not matter what you do. Now, if you think you are feeling confident and you want to try it yourself, pause it and do it the way that you choose. I am going to simplify the insides first and apply the exponent afterwards. So that means I'm going to start with a to the negative 1 minus 2, b to the 3 minus 4, and then c, except remember the whole thing is still raised to the 6th power. So that's a to the negative 3, b to the negative 1, c, all raised to the 6th power. Power of a power I multiply. So a to the negative 18, b to the negative 6, and c to the, careful, 1 times 6 is 6. And remember your invisible fraction. These guys have to live downstairs to become positive exponents. So we end up with c to the 6th over a to the 18th, b to the 6th. Last problem is this crazy convoluted thing inside the parentheses with negative exponents and negative numbers and all that craziness. Let's start with the simple stuff. Negative 4 squared we can do, that's 16. Negative 3 to the negative 3 power, that's going to take a second for me to figure out what to do with it. Well, if it's got a negative exponent, let's move it upstairs, keeping in mind this whole thing still has to be squared at the end. Let's move it upstairs and make the exponent positive. So now I have 16 times. Keeping in mind that 16 cannot switch parts of the fraction purely because the other part of the expression is switching parts of the fraction. Negative 3 to the 3rd power is negative 27. So this is 16 times negative 27, the product raised to the 2nd power, which means I have 16 times negative 27, which is negative 432. And then I'm squaring that, which comes out to be, 186,624. And that is the final answer for that particular problem. So, practice, 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 practice. The menus that you want to go to on IXL specifically are menus V and Y under Algebra 1. In all seriousness, guys, study, study, study. Okay, make sure you practice these new skills. See you in class.